welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or experimenting with something that you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing David Halter about Jedi, an awesome autocompletion and static analysis library for Python. So, Dave, could you please introduce yourself?
Well, I'm Dave. I do some work, some open source work, mostly on autocompletion stuff. You might know me from the Jedi library. I work for a company called cloudscale.ch. We're basically doing the cloud stuff like DigitalOcean, but for Switzerland, like that. So that kind of direction. If you're ever interested in good cloud hosting in Switzerland where privacy is still somewhat active. I like doing all kind of creative things where I think programming is one of the things that I really do a lot, but also very many other things.
And do you remember how you first got introduced to Python?
Oh yeah, that's kind of funny because like it started out with a boss that looked for a better language than PHP. I wrote like 1,000 lines of regex in PHP, which makes no sense at all. But so that's kind of how it started, and then he forced it on me. Kind of, but it was a good choice.
And so can you start by explaining what the Jedi project is and the problem that you're trying to solve when you first created it?
So how it started was very simple. When I started working in Python, I didn't really use an IDE. I used Vim. And for Vim, there wasn't really good autocompletion. And I think still there's not a lot else in the Python world other than Jedi and PyCharm. And so I just thought, well, why wouldn't I kind of improve that state of the art? But at the same time, I was very new to Python, and I also think that I wasn't the best programmer back then. So, but I just started, and it kind of grew.
Yeah, my understanding is that at least for Python autocompletion and Vim, there's the uCompleteMe project and NeoComplete, both of which are decent, but I definitely think is far and above the best one in terms of Python completion for the Vim editor, as well as many others. And when you were creating the project, how did you settle on the name of Jedi?
Well, I think before we clear the name, like one thing first is that like if you're using uCompleteMe, you're using Jedi below. Like for like if you're using it for Python autocompletion, if you're using it for C++, there's other stuff that does it behind, but uCompleteMe is not a completion library. Like so there's like one of the confusions a lot of people have around Jedi is that there's now two projects called that are maintained by me, or mostly by me, and one is called Jedi and one is called Jedi Vim, and one is like the plugin for Vim, like there's Jedi Emacs and other stuff, and one is the autocompletion library, and the autocompletion library is used for a lot of different plugins and editors. Yeah, for a lot of different editors and IDEs. Okay. So the name itself is like, I think my idea was just that my name should be in there, and like Jedi is part of my second name. And so that was kind of a fun play with the name. Now I'm a bit afraid about trademarks, I guess. because it might not be the best choice after all, even though it's a fun name.
Yeah, I think Jedi has become so colloquial that it basically exists as its own word in language, as independent of its original incarnation with the Star Wars series. And so when I was reading through the documentation, I noticed that there's also alpha support for linting capabilities within Jedi. And I'm wondering if you could compare and contrast the approach that you take for linting and the capabilities that it has in contrast to other tools such as pylint or flake8 that people might be familiar with.
So I think the alpha support is really something that started out a few years ago, and I've kind of given up on it for the near future. I still think it has tremendous potential for the far away future, but not for now. The idea is basically that if you compare it to the Flake project, I think it's called Flake, right?
Yes.
PyFlakes, or Flake8. Yeah, Flake8 is the combination, but PyFlakes. So PyFlakes is doing some stuff really, really well and is really, really fast, but it doesn't really find all bugs it potentially could. So if you're cross-referencing from one module to another, PyFlakes will not find that. And so the time came where I kind of started realizing that if you're writing a lot of type inference, you can also combine that and start doing static analysis with it and all of the other stuff that is kind of advanced IDE stuff, where like refactoring, or also now there's a library that was called PEP8 and is now called PyCode style, and it's basically just printing out issues that you have in your code that are not like programming mistakes, but style mistakes. They're like stuff that doesn't conform with PEP8. And that is also something that I'm now working on, but that might not even be part of Jedi, but be part of another project called Parso.
When I was reading through the documentation, I did notice that, as you said, you have your own parser that you're using for destructuring the Python syntax rather than using the AST module built into the Python language. So I'm wondering if you can explain a bit about why you found the need to write your own parser rather than using the built-in AST and some of the benefits and trade-offs that has enabled.
I didn't actually start writing my own parser. In the beginning, I kind of did, because the biggest problem you have in autocompletion, contrary to kind of static analysis, is you have to deal with broken code. Like, you want to be able to say foo dot and then have a completion, and that is already broken code, because that is not valid Python. So I think in parser theory, you call that error recovery. And error recovery is something kind of hard to do in the beginning if you don't know how you're doing it. And so I kind of I made so many mistakes there until I realized that I could actually be using a real parser and not do all by myself and with my hands. And so I started noticing Guido van Rossum's lib2to3 parser that he wrote. And basically, the parser that I'm using now for Jedi is the lib2to3 parser, just with a few additions like error recovery. And I mean, there's a lot of code around it, but in essence, and in the center of it all, there's still Guido's parser. And I think the parser idea is also important. I still actually want to do refactoring with Jedi. And if you want to do refactoring, you have to know, you have to have all the white space information, so you can kind of modify a syntax tree and generate code from it again. So you don't have to, that's just the easiest way to make refactoring work. It's called also in parser theory, it's called round trips. So you can actually parse something and then have your parser tree and then call a function on it, and you have code again.
And what led you to choose the lib2 to 3 capability for parsing rather than some of the other parsers that are available in the Python ecosystem, such as Ply or PyParsing or things like that?
That's actually a good question. I think like the biggest reason is that Ply and PyParsing and so on, they are not parser generators. And I think most of the listeners here might not know the difference between a parser and a parser generator. But basically what Python does by itself is you give Python a grammar file. You can Google for that. There's a Python grammar file that is very nice to read and very, very obvious what it does. So the theory is that you can actually write a parser that parses that file and checks for what your structure, and checks for what the structure is of that file, and builds a finite automaton or something like basically it just uses that parser file, that grammar. It's called a grammar file. It uses that to build a parser from it. So what you're writing in the end, what a parser generator is a parser for grammar files, and then kind of wrapping that or generating a parser. It's kind of weird, the concept of it, but what I like about it is that you can actually have, with a parser generator, you can actually have different grammars. So if you want to both parse Python 2.7 and Python 3.6, you're going to need a generator, right? Because if something in the grammar changed, you have to write a lot of Python code somewhere if you don't have that. But if changing for me from Python 3.5 to Python 3.6 was just adding a different grammar file, and the whole thing still worked.
Yeah, I know that issue crops up whenever there's a new release of Python for things like pylint, is that it takes a little while for them to upgrade the pylint repository to be able to lint the newer version of Python, because of the fact that things in the AST have changed, and so there are different attributes that it doesn't recognize yet, so you have to wait for their upgrade cycle after the Python upgrade cycle completes. And so it sounds like with your approach, what you're doing is you're actually just pulling in the grammar files that are defining the specific version of Python and then associating that with whichever runtime you're executing against?
Exactly. Like, you just save those grammar files, and they're not long. It's like, if you look at it, it's like 50 lines of code. And that's really awesome, because now you have like 6 different Python versions and 6 times 50 lines of code, and you can parse them all. Obviously, what you still have to do is there's this second step after parsing that is called type inference. And you have to basically, once the async statement came in, like, there's new types in the language. So it's kind of, you still have to do some work, but at least it's not like, oh my God, I'm doomed. There's like this new keyword and now I need to write new functions to parse it and also do the inference stuff. Now you're like, with parser generators, there's only half the amount of work.
And it sounds like it's also a little bit more robust to failures for when that new syntax does get introduced, because the parser generator will still be able to churn through the actual source code and generate a representation of it. It's just that as you're going through for trying to build the autocompletion, there may be just a few holes where it's not able to recognize what's going on, but it will still be able to operate on the rest of the syntax that it's already familiar with.
Absolutely, and like, that's one of the big reasons why I'm releasing this thing, because it will actually empower a lot of projects like the PyCode style project, or like the YAP project, or like maybe pylint if they consider switching, and so on, where like they just have an issue, like they have. If you're just using the ast module, which is fine, but if the code is not correct, it will just, like, everything will just fail. And with the parser approach that does error recovery, like that's actually a big empowerment for a lot of projects, and makes a lot of stuff possible that was previously very, very hard to do and involved a lot of manual work.
And so we've talked a bit about the parsing capabilities that are used for Jedi, but I'm wondering if you can dig a bit further into the internal architecture of how Jedi operates and what the overall design architecture looks like.
Well, I guess like the biggest part at a high level part, there's like three parts of Jedi. Like one part is very simple, that is just the API, where like some stuff is made public and some other stuff is not. And then there's like two central integral parts of Jedi, and one is the parser and one is the type inference. And we've talked a little bit about that. I think we don't need to talk about the parser in detail anymore. Maybe we can do that later. But so the type inference is kind of complicated because it involves a lot of manual code. If you actually want to have a good imagination of how type inference works, it's actually kind of similar to a compiler, where instead of getting one type in the end or one value, you get multiple values. And what's also interesting in type inference, I think that's what almost all people are doing, is instead of analyzing code forwards, you're analyzing code backwards. And analyzing code backwards means there's a lot of recursion. So what you do is if you have a function call, you first analyze the return statement of that function call, or the return statements if there's multiple ones. And once you have analyzed, like you check what it returns, and if it returns a name foo, that name foo is looked up. And so that's kind of how it works. It's just recursing over all that stuff. I think I'm not exactly sure because my university degree has been a while ago, but I think you can also call it backtracking. That's kind of what it does.
So you were talking about backtracking through the code and trying to infer the types of the potential return values for a function, and particularly for cases where there are multiple return statements based on different conditionals. What are some of the unique challenges that are posed by trying to understand those different types and be able to generate appropriate completions given how dynamic Python can be?
Well, I think like there's the standard kind of backtracking approach that is very easy. Like you can even program that very quickly. Like it's a lot of work, but it's not impossible. Like what gets really hard is that in Python, oftentimes you want completion if you're inside a function. What's the value of that parameter? And so you kind of have to recurse for that parameter as well. Like you have to search function calls. And so that just gives you very nasty recursions. So you have to be able to kind of stop your program at some point, to be able to, you want to be able to still analyze some other parts of the program if something is a dead end, but it shouldn't take too much time. So performance is very much an issue with autocompletion because you want it in real time, right? One of the other core issues we've had is basically lists and like all those container types, or let's call it state. Like in Python, you can just put anything inside a list and try understanding that. Jedi does some analysis on it, like you will get completions on lists and stuff. It's not perfect, but it's probably better than PyCharm and others. So yeah, I think those things are the biggest issues. And then there's just stuff that you cannot understand with autocompletion, stuff like meta classes. Like try understanding a Django meta class. It's just impossible. You can kind of imitate it, but you have to hard code it. It's not something your program will understand. You have to, for each and every meta class, you have to write code to understand it. And so that is just something that doesn't scale really well, which is unfortunate because it would be really nice.
And is it possible for a user to provide those definitions to Jedi so that they can have a sort of maybe a plugin for Jedi for their particular project so that it is able to provide those completions for some of the complicated edge cases that Jedi might not necessarily be able to intuit on its own?
There's at the moment no plugin system. It's definitely something that is kind of planned. It's just kind of hard to implement that stuff right, because it's kind of a chicken egg problem with plugins. If your API doesn't exist, nobody works with it. So you have to be the first user of it. Like, you have to create a plugin yourself, because just creating a random API doesn't really help most of the time. So yeah, in conclusion, there's no API. It's kind of planned, but it probably takes another year, because there's virtual env support is coming, like proper virtual env support, and that is definitely, for most people, is more valuable.
And in addition to being able to complete the point in the cursor, where, for instance, if you're trying to complete the bar attribute on an instance of the foo class, that's something that a lot of people would be able to understand. But one of the other things that Jedi can do is to actually find all of the usages of a particular function definition as well, which can be quite useful for things like refactoring or just doing code exploration when you don't necessarily know all the different places that something is happening. So are there any differences or additional complexities that arise from being able to provide that capability as well?
I think usages is, in my opinion, it's just horribly bugged. Like, I have to I or someone else has to rewrite that stuff. In my opinion, like, now it's not a lot of additional complexity, because I've refactored Jedi's internals for like the fifth time now, and so it's getting less and less code that you have to write to make something like usages possible. The biggest challenge there is that it's just very hard to not take 10 seconds for such a search, because usages is just like, if you search like 1,000 files, it will just take a long time. So in general, usages or also refactoring stuff, it's just a time constraint that makes it hard.
Yeah, it sounds like something where you would need to create some sort of caching capability where, as you're parsing the source of the project that you're working with, you would need to necessarily cache the parsed representation so that you could then use that as a search space for the usages capability, so that you don't necessarily need to repeat the same operations of finding all the places that something occurs.
Yeah, I mean, that's definitely true, but that's something we already do. We do some caching, like we do caching of parsers, but the bigger problem is that you also have to cache the references of those files, like the cross references of like modules. Like when you start caching cross references, it's just a very hard problem, because you have this big graph, and once one node is invalidated, it basically invalidates everything. So that kind of story. And a lot of companies actually work around that by not always providing, like take PyCharm, for example. I think the way how PyCharm does it is either they provide sometimes invalid suggestions, but they don't really matter because they hide it very well, or they just, like, it takes a lot of time in certain edge cases. And I think they just have, like, they work a lot more with databases and that kind of stuff, where Jedi is really something almost stateless, except for parser caches.
Yeah, it's definitely a difficult problem, and in my own use, I generally tend to fall back on things like grep and ag for just searching for the particular string that I'm trying to find all the usages of, but there are some limitations for that, particularly if you're trying to find a function that has the same name across different modules with potentially different function signatures.
But does it work for you? Does it actually, like, are you actually using it? Because I'm not. and I created it.
I think I've used it a few times in the past, but for the most part now, I generally just rely on grepping the code base for a particular function name, which most of the projects I'm working with are small enough that it works fairly well. But there are definitely cases where you have a sort of common method name, and so you have to try and visually parse, okay, this is coming from that module, this is coming from that module. You need to do some of your own sort of visual analysis, where if it was built into the tool, it might save you a bit of that time.
I see that. Yeah, I also use grep a lot, so that's also my poor man's method.
Yeah.
But it will get better. It will get better, I promise. Like, it's not finished. Like, that's not where it ends.
Yeah, it definitely seems like a fairly complicated and difficult problem to solve, but if and when it does become sort of more robust and production grade, it's certainly something that I would happily take advantage of.
Me too.
Speaking of ways that analyzing users' code is difficult, particularly in terms of trying to find the usages, what are some of the other edge cases that Jedi runs up against that it has difficulty trying to perform completions of, or some of the other maybe project structures or sort of module imports that can confound Jedi in the process of trying to find appropriate completions?
Well, I think there's a lot of stuff that can kind of make it not work, but we've gradually kind of improved, and I think there's a small list of things that Jedi just cannot understand at the moment, and some of it will not be possible in the future either. Like some of the issues involve calls to locals and globals, to those functions. Then there's like stuff like set, if you call set. There's obviously meta classes that are just impossible. Like set would be kind of possible, maybe in the future, but it's really hard. And then there's a lot of binary code. I think that's, of all of the things that I mentioned, like that is the biggest issue, that if you're using PyQt or PySide or whatever, like all those Python libraries that are written in C below, completions are just lacking because there's no way to really understand that code. It's just, I mean, you can call dir on it, but you cannot, if there's no docstring that kind of explains what it returns, you just have no idea what it returns. And I think that's the biggest issue for a lot of people.
Yeah, when I was reading through the documentation, I was noticing that when you refer to the subject of trying to perform completions on binary modules, it sort of violates your safety guarantees of not actually executing any of the Python code to generate the completions, because you don't have any other way of understanding what the sort of function signatures are that are available from that particular module.
Exactly. Like, there's no security that Jedi doesn't execute code. Jedi doesn't really execute Python code. There's one exception for now that we will fix, but it's not. But at the same time, like, you will be executing that code most of the time.
Right.
But it's not a good feeling. Like, it doesn't have a good feel coming with it. I don't like that it is that way. Like, a tool should be safe.
Sure.
By default.
And by virtue of the fact that it actually doesn't need to execute the majority of the code that it's working with to perform its analysis, it seems like it could be a potential benefit for building tools on top of it for doing things like security analysis of the project to try and find vulnerabilities or even maliciously inserted modules.
Yeah, exactly. That's something I wouldn't do now.
And you also briefly alluded to the fact that because of the fact that you are actually parsing the code and not just relying on the AST, you're actually able to use docstrings to be able to infer things about the function signatures of the code in question, as long as it's formatted appropriately. So I'm wondering if you can talk a bit about how that works and some of the mechanisms that you're using to be able to evaluate and understand those docstrings.
Well, understanding docstrings is actually not that hard. It's like that part of Jedi where I have done the least amount of work on it, because a lot of people actually like that functionality a lot, so they contribute to it. It's kind of the same with PEP 380, or was it 430? I'm not sure. Like the PEP that introduced type annotations, but coming back to docstrings, it's just checking for certain patterns. It's a little bit of regex, regular expressions, and once you're done with that, you just statically analyze the expression that's there. Like, there's not a lot of magic to evaluating docstrings, I think.
Yeah, I think it really helps that there are such well-established standards for the particular formatting of docstrings within the Python community so that it simplifies the job of actually trying to get meaningful information out of it.
Yeah, I think that is very, very helpful. There's like 2 or 3 competing standards, and that is very easy to work with. And I also think that adding doc types to your docstrings is kind of a thing of the past in at least Python 3.5 or something, because adding them as type annotations is just way nicer and way more readable most of the time. And it helps with understanding the code.
And with the introduction of the typing module in 3.5, it's also more functionally applicable as well, so that rather than having to go to the docstring itself to try and mentally compile how things are hanging together, you can actually use that module and other modules built on top of it to let the computer do that work for you.
Exactly. And like there's a lot of things. Once like docstrings get very old sometimes. And I mean type annotations can also get old, but at least if you're referencing your own kind of classes and you rename them, you will get actual errors. And that is something very nice, I think. There's tools and that like even the runtime throws errors there. And like also with the introduction of MyPy, I think there's a lot of work going into a direction where you can actually kind of validate certain parts of your programs. And I like that.
And we've talked about some of the different technical difficulties that you have encountered and overcome in the process of building Jedi, but I'm wondering if there are any others that you'd like to highlight.
There were so many, but like I think by large the biggest mistake I've made was that I didn't use a real parser in the beginning. That cost me probably a year of work. And by year, I mean a year of like working full time. Because what I did was just kind of play around with Python, but it wasn't really well programmed. Like it's just, and that's what I kind of realized, and what I'm now getting better at is that if you don't do something right, it will bite you sometime. And it has really given me a hard time that I didn't have that. And now I'm slowly kind of getting back and cleaning up my code, removing a lot of old stuff that is not really needed anymore because there's a proper representation of your code and not something fuzzy that you have to deal with, where you have to write a lot of ifs and loops to analyze stuff that is not valid anyway, that is kind of partially valid. Now you just know either that code is valid and you analyze it, or you don't. And that is kind of my big learning, I guess. And the biggest technical challenge, kind of removing the old parser and replacing it with a new one, which was really, really hard because you can kind of imagine that replacing a heart of something, like the parser is really the lowest component. Like you build on that, like the parser tree that you get is where like everything ends. Like there's not really a lot of things you don't have to touch if you remove the parser. So I basically rewrote the whole thing.
And are there any projects or libraries that you have seen using Jedi in unusual or unexpected ways?
Well, I think there's a couple. One of the things that I kind of like seeing is that sometimes at conferences or even by mail, some people write me that, oh, we kind of used your library, but it's just internal in our company's own editor, and I'm kind of wondering why they're writing their own editor. But anyway, like that's kind of funny to me. And I think the second one is IPython now. IPython version 6. So starting with version 6, IPython comes with Jedi. And there, Jedi is not used as the classical static analysis library, but more of please also do that sometimes, but analyze the objects that we give you. And so that makes autocompletion great in IPython now, and that's very unusual and very new for like a lot of people didn't think that was actually possible, but it is.
Yeah, I've actually got my personal RC file for my Python shell as well that uses Jedi just within the regular REPL, because of the fact that it does provide so many niceties of when you're just trying to do exploratory analysis of a particular code base or just trying to feel your way around a particular problem. It's nice having that easy auto completion. So having that as such an easy addition to any Python terminal is quite useful.
I think so too. I'm kind of like, sometimes it doesn't work and I'm not really sure why. I'm hoping that will improve a lot now that IPython is using it, because it's an extremely large user base. And like from the beginning on, I've gotten a lot of issues that we can fix now, and like a lot of feedback, and that's very nice. There's more contributors coming because they want certain things fixed. And so I really hope that REPL autocompletion is improving and is going to get even better.
And are there any other features or projects that you have planned for the future of Jedi?
Well, there's like I said, kind of my roadmap is virtual envs, understanding virtual envs, and like being able to switch between virtual envs and like making that possible. I think that's the first thing I'm going to do. Then refactoring is something that will come to Jedi. That might still take a long time, but it's definitely in the works. There might be like one of the things I'm thinking about is actually supporting Django with a plugin architecture, and also maybe its language, its template language. So kind of branching out into cross language support. That might be interesting, because now I kind of have to, like, I feel like I'm getting closer to actually knowing how I can understand the language in a really fast way, because what I've been doing now is mostly improving my code base and not adding features to it. So like the last 3-4 years were not just features. Mostly it was just refactoring, and not the refactoring feature that might come to Jedi, but refactoring Jedi's code itself. So yeah, I have a lot of plans and ideas. Like I've even had the idea of like maybe creating a Rust autocompletion, but that's kind of far away, and like it's also an issue for me because I don't have extreme amounts of time. I have like maybe 10 to 20 hours a week. It's kind of it.
It's nice to be able to have that amount of time to dedicate to open source, and we all appreciate your efforts. It's definitely not always easy to find the time to be able to work on things like that because of other pressures in life.
Oh yeah, it is. Like I'm in a good space. I'm not that old. I don't have a family for now. I work 80%. I don't work 100%. So I have a bit more time, but still it's a challenge. But I just like doing it. Like it's just so much more relaxing than working at a company where you have to perform, and here something can just take half a year. People will be happy that it's out after half a year and not after 2 weeks.
Yeah, that's definitely great being able to have side projects like that, because it does give you more room for creativity without necessarily having to work through the pressures of whatever the external requirements are, and it lets you have a lot more self-direction.
Oh yeah. And it's like the biggest problem is that it's financially just unsustainable. Like that's still I think my biggest issue, that you can just not really make money with it, especially if you want to make it perfect, which is good basically, but still.
So are there any other topics or questions that you think we should cover before we start to close out the show?
No, not really. Like, I think I would recommend people to watch out for Parso. Parso is coming in like a month or two. It's a Python parser for everybody that is working with static analysis stuff. That might be really interesting. But yeah, for me, that's it.
So for anybody who wants to get in touch with you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us to the picks. And this week, I'm going to choose the Unix patch utility, which lets you download a patch file, for instance, from a GitHub pull request or from a diff, and then be able to apply that to another code base, because there are times when just relying on your version control system to be able to provide those merges isn't necessarily practical, and being able to have that utility to fall back on is quite useful. In fact, I ended up using it just yesterday. So with that, I'll pass it to you. Do you have any picks for us today?
I'll start off with a band. It's called Bears Den. Really nice band. Like listening to them. They're awesome. And then there's like all the creative stuff I mentioned in the beginning that I like doing. Like in the last few months, I think it was like soccer, singing, and dancing. That's really awesome. I like, and then for technical stuff, I have one thing called DocOpt. DocOpt is it's a competition to arc parse and those kind of things, where it's just very easy to build command line interfaces. It just makes your life easier. You just write documentation and everything's working, basically. Really small library, but really good as well. And the other technical thing I have, I just thought I'd mention it because nobody ever mentions it, is OpenStack. I actually like, we're working on it with our company, but I actually like how clean the code base is. It's for how large it is, like it's a few million lines of code, I think. It's just very, very readable. And I really like that, because most of the open source code I've read is not. So yeah, I think if you're ever planning on using an open source cloud solution, OpenStack is really in a good place.
Yeah, it's definitely a very sizable project and very ambitious project, but I've used it a few times and it's definitely quite nice.
Oh, yeah.
All right. Well, I appreciate you taking the time out of your day to join me and talk to me about the Jedi project and digging into its past and its internals. It's definitely one that I use pretty regularly, and one that I'm happy to continue using. So I appreciate your work on that, and I appreciate your time.
Well, thank you a lot for this interview. It was really nice talking to you.